Alrighty, everybody. I just got the okay to start our planetarium show. So for now, I'm going to put away our space trivia questions because now we're going to be heading into the unknown. Ooh, ah. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. And I'm not just a voice coming out of the walls, I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm here. I'm going to be your pilot, your driver of space of sorts. And just to let you know, folks, everything that you're about to see on the screen is going to be projected in purple. So that's our entire screen. And it's put on by 6 different projectors hiding throughout our planetarium dome. We've got 2 at the bottom, 2 at the middle, and 2 at the very top. And just to let you know, folks, the show that we're going to be doing right now is one of my personal favorites to do. It's called Tour of the Universe, and this show's about 30 minutes long. So pretty much you're going to hear my voice for the next 30 minutes, and I'm going to take us from Earth, pretty close to Earth, and we're going to zoom all the way out to the very edge of the known universe. Hopefully by the end of this show, you won't have an existential crisis of where we are in space. Just to warn you, we are very small in the grand scheme of things out in space, so just a heads up. But before we get started, I got to go over some quick house rules just so that we're all on the same page. We're going to have great experience inside the planetarium. First off, folks, there is no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are tucked away to the very end of the show. We want to keep this theater nice and clean for all of our guests coming in the future. We do appreciate it. This also does include no feetsies on the seatsies because, again, we want to make sure the seats stay nice and clean for all of our future guests. So thank you for keeping the feet on the floor and not on the seats. We do appreciate it. And also, folks, if you happen to have any of these 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now is the perfect time to turn them off, put them away for the next 30 minutes. Again, these devices produce really bright white light that can be distracting not only for yourself, but for the folks sitting behind you, because this room is going to get quite dark. We want to be courteous to all of our guests here in the planetarium dome. And also, folks, the biggest of them all, please, wear your mask above your nose at all times while we're in the planetarium dome. It looks like there's about 70 of us here in the dome. We're going to be here for 30 minutes. And again, above the nose, because your nose is an airway, you'll breathe out of the nose. So we want to cover those up. Thank you so much, y'all. We do appreciate it. And also, folks, if you need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. So when in doubt, always go up the stairs, not down them. And last but not least, folks, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, well, there's a really quick and easy solution to help ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling out into the universe, at least not more than the usual. Hee hee hee. But otherwise, that's all I have to say. Y'all ready for a cool planetarium show? Alrighty, everybody, sit back, relax, and here comes Tour of the Universe. All right, folks. So, as I mentioned, we're starting off pretty close to Earth, not exactly right on it, but we can see our Earth just below us, right over here, that huge marble just below. And we're starting off a little bit away from it here at this thing called the International Space Station. We also like to shorten it by calling it the ISS. And what's really amazing about the International Space Station is that it's the biggest thing we humans have ever put into orbit around our planet Earth. And this thing stretches out about the size of an American football field. If you've never been to an American football game, don't worry. You can use the entire California Academy of Sciences as to give you an idea of how large it is. But yeah, so the International Space Station is a research facility that's orbiting around our planet. Pretty much a bunch of countries around the planet Earth wanted to figure out what happens to things when you put it out into space. For example, what happens when you try to grow plants out here in space? Do they grow the same way as they do closer to Earth? Do they grow differently? What happens when you try to drink water in space? Is it different from being on Earth? And of course, what happens to when you try to spark a match? Does the fire behave the same way closer to the Earth with much more gravity, or does it act differently? So these are some of the different questions that scientists want to figure out. And just to let you know, folks, the International Space Station looks really far away from our planet, but it's not too far away. It's only about 250 miles above the surface of our Earth. 250 miles, that's like going from San Francisco to Santa Barbara a nice little road trip with the family to get away for the weekend. And one of my favorite things is that this thing, the International Space Station, is going incredibly fast, y'all. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And just to let you know, the International Space Station fits about 6 to 8 astronauts at a given time. Not a whole lot of leg room. They mostly hang out in these modules right over here. And just to let you know, folks, this is as far as we put humans out into space nowadays because traveling out into space gets quite expensive quite rapidly. First, you got to get your hands on a rocket ship or build yourself a rocket ship, and you have to get your hands on a whole bunch of rocket fuel, and I mean a whole lot of it. And then once you get that, you have to also account for all the food, water, all the air you're going to be breathing while you're in space. So the bill gets really expensive really fast. So this is as far as we put humans into space nowadays. But let's leave the International Space Station. So now we're going to start to slowly see the space station slowly fade away compared to our planet. And it looks like we're hovering just above Australia right now over the outback. So we're going to slowly see the ISS disappear. And before we lose sight of it, I do have a nice little trajectory line so we can keep track of it as we zoom away from it. And folks, just to let you know, the space program that I'm using right now is something you can technically go home and download if you want to fly through space or the universe, just like how I am right now. If you type in your favorite search engine, OpenSpace Project, you'll find the software and you can download this at home. But just a heads up, OpenSpace is in its beta phase, which means it's not completely finished, which means we might run across a few glitches or bugs here and there. If we do, I'll point them out and let you know. And also, just to let you know, OpenSpace uses a whole lot of processing power and memory. So if you don't have a newer computer, I wouldn't recommend downloading it. It takes up a whole lot of memory and a lot of processing power. But if you don't want to download anything and you still want to fly through space, we have another cool space program that you can use, which is called NASA's Eyes, just like your eyeballs. So you just type in your favorite search engine, NASA's Eyes, you can fly through space without having to download anything. But let's leave our Earth because we've zoomed so far away now. And now we're going to head over to our nearest natural neighbor to us in space, the moon. And it looks like we are in, just a tiny sliver of the moon. We can see it right there. Luckily, we are inside of a planetarium, so I have some special abilities here. I'm going to turn off the nighttime on the moon. Hey, look, there it is. That looks familiar. Alrighty, folks. So now we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972. Thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, conduct science, and of course, they got to goof around and play golf. So you can always have fun anywhere you go. But again, that was a while ago. Last time was in 1972, a little more than 50 years ago. Now, just to let you know, NASA has a new space mission in the works that's going to be sending humans back to the moon in the next year or two. Hopefully, everything goes according to plan. This new space mission is called Artemis. Pretty much with Artemis, they want to send humans to Mars, but before we send humans all the way deep into our solar system, we need to figure out how we're going to live independently out here in space. So the moon is the closest celestial object to us, which is a perfect stepping stone to figure out all the logistics, how we humans are going to live out here in space. So with Artemis, they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases all over the moon. So pretty much they're going to pick different sites that seem very interesting and more appropriate for humans to live around. So let's say they like this spot, we'll set up a base there. Maybe they like this spot, they'll set up a base here. And if anything was to go wrong, they're going to have a space station orbiting around the moon called Lunar Gateway, similar to the International Space Station that we just saw. So again, if anything was to go wrong on the surface base, they can blast off and then head back to that space station where they'll be safe. So again, in the next year or two, we should be having humans back on the moon. Again, cross my fingers. Hopefully everything goes according to plan. So look out for any news about Artemis in the coming years, y'all. And also, folks, here on Earth, when we look up at the moon here in the nighttime, it feels incredibly close. Sometimes it feels like you can reach out your arms and touch the moon, but the moon is incredibly far away from us. It's about 240,000 miles away from us here on Earth. 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers instead use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, we must leave the moon, so everybody say bye bye, moon. We'll see you later. And now, folks, we're going to be heading out to a much greater realm of our solar system because now we're going to watch the moon and the Earth as they slowly recede. In fact, let me turn on their orbit so we can see where they're at because once we zoom out, we won't be able to see much stuff out here in space. So these orbit paths help us a lot. But we can see the moon right there. There's our Earth. And now those orbits are slowly fading away. And folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination thanks to the help of computer models like OpenSpace, showing us the most accurate information and images available to us. And now here comes the sun, this our star, the sun right there, comes into view. The sun's about 93 million miles away from us here on Earth. Whew, 93 million miles away. That is a great distance away. But in terms of at the speed of light, that's not that far at all. So again, our sun's right in the middle. We're the third rock from the sun on the top right. So that distance is again 93 million miles. But if you're traveling at the speed of light, that only takes about 8.5 minutes at the speed of light to cross that distance. Now, this is a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, we wouldn't know it here on Earth for about 8.5 minutes because that last bit of sunlight would be emitted and it would travel that distance, 8.5 minutes pass, and then the daytime would turn into nighttime here on Earth. Now, that's also a great concept to keep in mind because this works for really far away objects out in space as well. For example, let's say we're looking at a star that's 60 light years away, like this one over here. Well, we're looking at that star as it looked like 60 years ago because we're just seeing the light that right now that it's been emitted. It's been traveling 60 years to get to us. So when we look at this star, we're looking at it kind of like back in time in a sense. So the further objects are in space, it's kind of like looking back in time, which is pretty cool. But we have a nice bird's eye perspective of our solar system. So really quickly, I'm going to name all the objects in our solar system. We've got our star in the middle, the sun. And then the closest planet to the sun is going to be Mercury. Then we have Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places we can actually land a spacecraft on. And then beyond the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. Give it a second. There's a whole lot of asteroids to bring up. There they are. So that's our main asteroid belt. And then beyond the asteroid belt, we have the really big planets. We have the gas giants. We've got the Jovians. We've got Jupiter, the largest planet. Whoopsie daisy. There's that bug / glitch I was mentioning earlier. So again, we have Jupiter right beyond the orbit of our asteroid belts. Then we have Saturn. And now we have our icy giants. We have Uranus and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. Here's the orbit of Pluto for y'all. And just to let you know, folks, Pluto hangs out here in the outer part of our solar system in a region called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of it. Well, the Kuiper Belt's going to be all this stuff. There it is. So again, this is the Kuiper Belt. This is pretty much a second asteroid belt way out here deep in our solar system. So you're mostly going to find icy asteroids and icy comets, short period comets. So we got a second asteroid belt all the way out here. But I want to put that away because that's just a whole lot to look at. And now, folks, I'm going to be adding some of the spacecrafts that we sent out in the 1970s to explore our solar system so we can learn more about it. And there they are. So on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, we have New Horizons. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. And what's also really amazing is that New Horizons, the latest of them, did a quick flyby of Pluto in 2015. We can see that interaction right over there on the somewhat center of our screen. And thanks to that flyby, we're able to get some amazing high definition images of Pluto. Because in the past, our images of Pluto were pretty much pixelated, fuzzy pictures. But due to that flyby, we got some amazing information. But let's leave our solar system behind, folks, because now we're going to leave the planetary system and now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. So again, our star system's right there, our solar system right in the middle. And if my calculations are correct, Alpha Centauri is going to be this top right star that's closest to us. So again, 4 years at the speed of light just to reach the next star system. Now, to give you an idea, if we were to get in a rocket ship today of our today's capabilities and we launched and we wanted to travel all the way over to our next star system, it's going to take us about 8,000 years. Woo, that's a very long road trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're about to step foot inside something called the radiosphere. So now we are inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And just to let you know, folks, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, right now I'm going to be adding some markers on the screen. Here they come. Now, these markers indicate some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found 4,000 exoplanets in the nearby vicinity to us. In fact, once we pointed our space telescopes in a certain direction, we were able to find a whole heap of exoplanets. In fact, as we start to zoom out, if you look on the very bottom left of our screen, we pointed our space telescope and we just found a whole bunch of exoplanets just looking in that one direction. And we have new space telescopes where their whole purpose is to find as many exoplanets as possible, so that 4,000 number is going to be increasing as the years continue. Now, to figure out if any of these exoplanets have life as we know it, suitable for life as we humans know, well, that's a completely different question. Our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted for that search. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system inside our radiosphere. Let's say this one. We find an alien civilization midway, right over here. We shoot them a text message. We say hi, takes 60 years to get to them. They listen in, answer back, another 60 years. That is a 120-year conversation in the making. Woo, and I can barely wait for a text message from my friend. He, he, he. And of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. I want to put away our exoplanet markers because there's a whole lot there, but I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. So let's zoom on out. Let's see if you can still see that radiosphere. Alrighty, folks, we're looking down at our Milky Way Galaxy now. Can anybody see their house from here? Hee hee hee. All right, so again, we're looking down on our Milky Way, and our Milky Way is incredibly large, folks. If you wanted to cross the Milky Way galaxy, starting from one side to the other, it's going to take you about 130,000 years at the speed of light to cross this one galaxy. And just to let you know, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be potentially billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way galaxy, folks, I do want to stress the shape of it. When we look at our Milky Way galaxy from a sideways perspective, you're going to notice that we live in a flat spiral disk of our galaxy. So keep this in mind. This is going to come important later on in the show. So when astronomers and scientists want to learn about the universe, it's so much more convenient for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way galaxy, which has planets, stars, gas, nebula, black holes, things that obscure their view of the universe. So keep that in mind. We look galactically north and south instead of looking through the plane of the Milky Way. But the Milky Way galaxy is one of many galaxies that comprise the known universe. And folks, now we're going to be zooming so far back. In this giant leap, we're about to see a view where each point of light no longer represents a star. It now represents the location of an individual galaxy, each galaxy containing hundreds of billions, perhaps even trillions of stars. Now, just to let you know, we live in a local galaxy group which contains about 30 galaxies, large and small. It also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. Hee hee hee. And as we start to continue zooming out, folks, you're going to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, and they like to form very large voids where there's very few galaxies. So we can see a nice galaxy cluster right over here. We can see another galaxy cluster here. And then you can see voids where there's very few galaxies. You don't see any galaxies there or over here. So you can kind of think of galaxies as humans. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far back out now that this picture represents the closest 30,000 galaxies to us in space over 300 million light years across. We got to give thanks to a pretty amazing fellow by the name of Dr. Brent Tully, who worked at the University of Hawaii, who compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So we have this amazing galactic map thanks to Dr. Brent Tully, so big shout out to him. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're going to be looking at the large-scale structure of the universe. And remember, folks, every single point of light is an individual galaxy. Woo, I feel small. And just to let you know, the large-scale structure of the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in the Milky Way galaxy, so astronomers point their telescopes galactically north and south? Well, that's still true. If we were to line up our Milky Way galaxy, it would line up horizontally just like this. So again, we look north and south. But scientists still want to make sure that there was galaxies through the plane of our Milky Way galaxy. So we have this nice purple survey of galaxies. You can still see they found galaxies, but just not as far and not as frequently. Pretty much we have to wait for our technology to advance. And once that happens, we'll be able to look through the plane of our Milky Way and we'll be able to fill in all those galaxies in these empty regions that haven't been filled in yet. It's only a matter of time. But we still have a ways to go to the edge of the known universe, so let's continue going, folks. And now we're going to be zooming so far back that now we're going to be looking at some really, really early objects known as the quasars. So the quasars are going to be represented by these orange data points at the very edge of the large-scale structure. We can see some quasars there. We can see some quasars we're about to fly through right now. Now, the quasars are short for quasi-stellar radio sources, and these are all blazing objects that are billions of light years apart, or they're all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press back to a time before quasars, before planets, before stars, and even galaxies began to form. Folks, we're about to see the very edge of the known universe. And here we are. So what we're looking at, folks, is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, what we're looking at is a temperature density image where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, which is back home. So let's find a nice entry point through all these quasars and galaxies. And before we make our return trip back home, I gotta ask y'all to prepare yourself because this could possibly be the worst free falling dream ever. Hee hee hee. Alrighty. So let's focus on Earth, get right in those clusters, and let's make our way back home, y'all. So, everybody, we are crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecraft that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind everyone that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way galaxy. We're heading right for that radiosphere. And of course, we are making our way downtown, walking fast faces past, and we're homebound. And it looks like we're now approaching our solar system, passing the spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and those Jovians, the largest planets in our system. And we're making our way to the third rock from the sun, our homeworld, the only place we humans have ever lived. And we're about to pass the orbit of the moon, which is as far as we've ever put humans out into space. So as we make our way back to planet Earth, folks, this is going to be the end of our tour of the universe. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But otherwise, that's all I have for you today, folks. Thank you.